Hi everyone, hope all of you guys are doing well, and this is the pre-lab assignment for enthalpy experiment, which is experiment 10b. So question 1 and 2, they are conceptual ones, you guys can work on that. Let's look at question 3. A 50-gram sample of pork rinds placed in an open constant pressure calorimeter that contains 3000 grams of water. Temperature of the water increases by 47 degrees when the pork rinds are combusted. The specific heat of water is given. Assume that the heat loss to the calorimeter itself or to the air is negligible. What of the following is true about the combustion reaction? So basically we want to find out the enthalpy of the combustion reaction. Now, the combustion reaction has taken place inside the calorimeter, which has 3000 grams of water. Water temperature has increased by 47 degrees Celsius. We also know the specific heat of the water. So, since the water temperature had increased, meaning when the combustion reaction is taking place, combustion reaction lost heat, and the water absorbed that heat. So for water it is absorbing the heat. So that is going to be positive enthalpy for the water. Heat gained by the water is going to be positive because the temperature increased. But for the combustion reaction it lost heat. So the enthalpy would be negative for that. So since we know the mass of the water, temperature change, and also the specific heat capacity of the water, we can calculate the heat gained by the water using this equation Q equals mc delta T. Here Q represent the heat lost by the combustion reaction or heat gained by the water. Q is also same as delta H, okay, because it's a constant pressure. Enthalpy is the energy when a reaction taking place at constant pressure. Okay, so mass of the water is going to be 3000, so we use water information 3000, and then the specific heat capacity is the C, which is 4.184 joules grams per Celsius, and then the specific heat of the water, we got that. Temperature of the water increased by 47 degrees Celsius. So when you solve this, you will get the answer Q, which is what we are looking at here is the Q water, and that would be, when you do the calculation, 590 kilojoules. But what is asking is, what of the following true about the combustion reaction? So what we just calculate is Q for the water, because the water absorbed the heat lost by the combustion reaction. So it is positive for the water. But what about for the combustion reaction? It lost the heat, right? What we want to find out is the enthalpy for the combustion reaction. It's going to be the same amount, but it's going to be opposite sign for the combustion reaction. So that would be negative 590 kilojoules. Okay. So the next one, easy. 0.5 gram calcium metal is added to 50 milliliters of 1 mole HCl. Once the reaction is complete, the temperature of the solution has risen from 25.2 degrees Celsius to 71.4 degrees Celsius. And then the reaction is given to us. What is the temperature change of the solution? So the temperature change is basically going to be final temperature 71.4 minus 25.2 degrees Celsius. So you guys can find out that answer and write it down in the space provided. Okay. And then the question 5. What is the heat lost by the reaction? In units of kilojoules. Assume that the density of the solution is 1 gram per milliliter and that the volume of the HCl does not change when the calcium metal is added. The specific heat of water is given. Type your answer in 3 sig figs. Okay. Now this reaction, 0.5 gram calcium metal is added. Let's say this is your hydrochloric acid, 50 milliliters, 1 molar HCl, and to this one you are adding 0.5 grams of calcium. To this one you add some calcium. So calcium with hydrochloric acid is gonna do a reaction. Calcium plus hydrochloric acid will form calcium chloride and hydrogen gas. Okay, now this is happening in this hydrochloric acid, and hydrochloric acid, we also have a bunch of water in it. It's not just the hydrochloric acid, it's dissolved in water. Now the calcium metal that we put, hydrochloric acid inside the water, going to react and form calcium chloride and hydrogen gas. Now when this reaction is taking place, this is going to release heat, and this heat is being absorbed by the water, because HCl is not all by itself, it is HCl plus water, is this 50 milliliters. So heat is being gained by the water in this hydrochloric acid, and then the heat is going to lose by this particular reaction, calcium plus hydrochloric acid giving you calcium chloride and hydrogen gas. We want to find out what is the heat loss by the reaction. Okay, again what we can use is Q equals mc delta T, but we don't know the specific heat capacity for calcium. What we know is the specific heat for the water. So we know the information for the water because we use 50 milliliters of hydrochloric acid, 50 milliliters. So that is about the same amount of water that we have in this hydrochloric acid. So we know the mass of the water, we know the specific heat of the water, and the delta T is what you just calculated by subtracting these two. So we can find out Q water with the given information. Mass of the water is 50 grams. Why 50 grams? Because we are giving 50 milliliters. So the density of the water is given, density of the solution is given as 1 gram per milliliter. So 50 milliliters you can easily convert to grams. 50 milliliters using the density 1 gram over here per milliliter. Density, by using the density, so since it's 1, basically 50 milliliter is same as 50 grams. So 50 gram water, since we use 50 milliliters hydrochloric acid, we have very small amount of hydrochloric acid adds the number of moles, so we can basically neglect the amount of HCl, considering all of it is water. Okay, so 50 grams, and then the specific heat for water 4.184 joules grams per Celsius, and then the temperature change which you calculated in question number 4, 46.2 Celsius. So when you do calculate this, you're going to find out the Q water. Okay, once you find the Q water, you have to answer that. That would be a positive number. Okay, you have to calculate in kilojoules. You will get it in joules, so you know how to convert to kilojoules. 1000 kilojoules equals 1 kilojoule. So this will give you a number like 9.67 kilojoule after you convert it to kilojoules. Now this is for Q water. What about the Q for the reaction? What we want is, what do we want? Where is it? Heat loss by the reaction. What is the heat loss by the reaction? So 9.67 is for the Q water. So then the heat lost by the reaction is going to be negative 9.67 kilojoules. Okay, that's how you calculate that. And then the next step is asking how many moles of calcium were used in this reaction. Remember, we use 0.5 gram calcium, 0.5 grams. You know how to calculate, how to convert grams to moles. What's the molar mass of calcium? You can look it up on your periodic table. Calcium molar mass is 40.08 grams. That's for 1 mole. And then when you calculate that, you will find the number of moles. Okay, and it would be something like this. Please do these calculations yourself to see if you are getting the right answers. I sometimes may have not used the 0.08, but you can do your calculations and check to see if they are correct. That's the number of moles. And then what is the heat of reaction per mole of calcium? Okay, so earlier we calculate the heat of reaction 9.67 kilojoules. Now we want to find out per mole. So what you're going to do is you take this number and then you divide it by the moles. This will give you per mole of calcium. Okay, you do this calculation and then you can put your answer there. And question 8. A piece of newly synthesized material of mass 25 grams at 80 degrees placed in a calorimeter containing 100 grams of water at 20 degrees Celsius. If the final temperature of the system is 24 degrees, what is the specific heat of this new material? Okay, so you have a new material. Let's say this is a new material. It is 25 grams and the temperature of this 80 degrees Celsius. And you have a calorimeter, coffee cup calorimeter. It already has 100 grams of water in it. And then the initial temperature of the water, 20 degrees Celsius. Specific heat capacity of water is given 4.184. We want to find out what's the specific heat of the new metal. Now, if you remember, we did a similar experiment in General Chemistry 1 when we did enthalpy, calorimeter. Using a calorimeter, how we calculate the specific heat of a metal. So basically, we boil it to 100 degrees Celsius, but here it is being boiled, heated up to 80 degrees Celsius. You put this metal in this water. So then, since the metal is at a higher temperature, heat is going to go to the water. The metal will lose heat and then the water will excuse me, absorb heat, right? So the water is going to absorb the heat, metal is going to lose heat. And then when you put a thermometer, you can see what is the highest temperature water reaches, and that would be 24 degrees Celsius. Okay, when it reaches the highest temperature, 24 degrees, at that temperature, your metal and water both are at thermal equilibrium. So the final temperature for both the materials are going to be 24. So with this information, we can find out the specific heat of the metal, because heat is going to lose by the metal. Q metal equals Q water. It's going to be positive for the water, negative for the metal, because the metal is losing heat. And basically we know Q equals mc delta T. So we can now find out the specific heat for the metal. Okay. So for this side, negative m mass of the metal, C of the metal, delta T for the metal equals mass of the water, specific heat of the water, and delta T for the water. Okay, so basically specific heat then going to be, mass of the water going to be 100 grams. and then the specific heat 4.184 joules grams per Celsius, and then the delta T, final temperature 24, initial temperature 20, so the difference is 4 degrees Celsius, and you divide this by negative mass of the metal. What is the mass of the metal? 25 grams. Okay, 25 grams, so 25 grams, and then the delta T. For the metal, the final temperature is 24, and for the delta T for the metal, final temperature 24 minus 80. That will give you negative 56. So negative 56. So we have two negative terms. So you can negative multiply, you get positive number. So when you calculate this, you can find out the specific heat for the metal. Okay, do this calculation and find out what would be the specific heat. Grams to grams, Celsius, you will get the answer in joules per grams per Celsius. Keep it in I believe 3 significant figures. Yeah. Or you can just answer the correct one. Choose the correct answer from the given choices. Okay. Next one, question 9, and this is for the Hess's law. Use Hess's law to calculate the enthalpy change for the reaction. So basically Hess's law says if you want to calculate enthalpy of a reaction, but you are not able to calculate that by itself, so then you can use several individual reactions and you add them up, and if you know the enthalpy of those individual reactions, by adding them such a way you get the target reaction at the end, that will lead you to find out the enthalpy of the reaction. Okay, now I will explain you what I just told you with these examples. There are two that we're going to do. This is the target reaction that we want to find out the enthalpy. N2H4 liquid plus hydrogen giving you 2 ammonia gas. Excuse me. We are given 3 different equations and with their enthalpies. Now what we are going to do now, we're going to rearrange these equations, these 3 equations. Once we rearrange them and add them up, we're going to get this target reaction. Okay, let's look at the first one. I'm going to label them as 1, 2, 3. First one, N2H4. So in our target reaction, N2H4 is a reactant. Here also a N2H4 is a reactant. So we're going to keep that reaction as it is. Plus oxygen. We're not going to reverse, or we're not going to multiply or anything or divide anything yet. So plus 2 water, and the delta H for this one is negative 543. Next one, hydrogen gas plus oxygen giving you water. Okay, we're going to keep that. So our target reaction also we have hydrogen as a reactant. Here is also as a reactant. So we probably keep it like that, but we will see if we need to reverse it. Let's look at the other one, the third one. Excuse me. Nitrogen gas plus 3 hydrogen giving 2 ammonia. Now ammonia is a product. So we're going to keep it the way it is. I'm going to write it down. N2 plus 3 hydrogen, 2 ammonia, negative 92.2 kilojoules. Now you can see here N2H4, hydrogen, and then ammonia. When we add these together, we might be getting our target reaction. But we also have here, we have water here, and then we have hydrogen and oxygen. So water is being formed by hydrogen and oxygen. Water is a product in the first reaction I just drew. So we need to take this reaction 2 over here and we need to flip it. Why we flip it? Because in the second reaction it is a product. So we want to reverse it. So we're going to reverse that reaction 2. That will give you 2 water. The product will become a reactant and then you have 2 hydrogen and 1 oxygen. Okay, and when you reverse a reaction, the sign of the delta H needs to be reversed. So negative 484 will become positive 484. Okay. Now let's see, when you add these 3 equations together, if we can produce our target equation. So here we have 1 oxygen in the left side, 1 oxygen in the right side. It cancelled. And we have 2 hydrogen. Okay, let's look at nitrogen. Nitrogen get cancelled. 2 water molecules get cancelled. So we're going to keep N2H4 plus. Here you have 3 hydrogens in your left side, and on your right side you have 2 hydrogens. 3 on the left, 2 on the right. So basically you can do a subtraction. 3 minus 2. What you left with is 1 hydrogen. You keep that. And in fact we need that over here. And then 2 ammonia. You see here what the Hess's law does? To find out the enthalpy of the target reaction, since we do not know that right away, you use individual reactions to find out the enthalpy of the target reaction. Now what you're going to do is you're going to add these 3 terms together. Negative 543, negative 92.21, positive 484. When you add up these enthalpy values, you will get the enthalpy of the reaction. So you choose the one best from this list. Okay, I will leave it up to you to find out the correct answer. Okay, and the next one is also similar. Use the Hess law to calculate enthalpy of this reaction. We have methane plus water giving you carbon monoxide and 3 hydrogen. That is the target reaction. So this is the one that we want to find out the enthalpy. Let's look at our first given equation. 2 hydrogen plus carbon monoxide. Now this one, carbon monoxide, is in the left side. So we want to put it in the right side. So we're going to reverse that first reaction. When you reverse it, it would become methanol, will become your reactant, and 2 hydrogen and carbon monoxide will become a product. So negative 128 will become now positive 128.3 kilojoules. So when a reaction is reversed, the sign of the enthalpy also need to be reversed. Okay, and then the next equation, 2 methane molecules with 1 oxygen giving you 2 methanol and 2 methanol. So in our target reaction, methane is a reactant. So here also it's a reactant. So we're going to keep it like that. Okay. So 2CH4 plus oxygen, 2 methanol, negative 328.1. We didn't do anything to this equation, but we just wrote it down. So the last one, the formation of the water, hydrogen plus oxygen giving water molecule. Okay, hydrogen and oxygen giving you water molecules. We also have water in our target reaction. So here water is a product, so we need to reverse it to make it a reactant. So we're going to reverse it to water decompose to give you 2 hydrogen and oxygen. Since we reverse it, negative 483 will become positive 483.6. Okay. Now, you see here we have 2 methanol right there. But methanol is not in our target reaction. We don't have any methanol here. So we want to get rid of methanol. We have 2 methanol in the second reaction. We have only 1 methanol in our first reaction. So what do we need to do to match them up? We need to multiply this whole reaction by 2. So when you multiply it by 2, it would become 2CH3OH. Will become 2 times 2 hydrogen, 4 hydrogen. The whole reaction need to be multiplied, and then the 2 carbon monoxide. Okay, everything need to be multiplied by 2, plus if you have an enthalpy, enthalpy also needed to be multiplied by 2. So that would become 256, and also we need to keep the same sign. This is positive. Now we're going to add these 3 together to get our target reaction. Okay, so 2CH4, we're going to keep it as 2CH4 plus oxygen. Here this oxygen get cancelled, and then we have 2 methanol get cancelled, and then we have 2 water here. It's not going to cancel, so we're going to keep it 2 water. And on the right side, you have 2 hydrogen here. You have 4 hydrogen here. So 4 plus 2, both of them are on the product side. That will make it 6 hydrogen, correct? 4 plus 2. And then we have 2 carbon monoxide. Excuse me. When you add these 3 reactions together, so then you can also add these 3 together. Negative 328.1, positive 483.6, positive 256.6. When you add them up, it would be 412.1 kilojoules. Okay, 412. We do have one answer like 412. But do you think the 412 is the answer? No. Why? Because you see here in the reaction, the bottom reaction, we just found the answer. This is for 2, 6, 2. But our target reaction needs to be 1 mole of methane. So basically we're going to divide this by 2. So when you divide it by 2, it would become CH4 plus water. 6 divided by 2, 3H2 plus carbon monoxide. So if you divide a reaction by 2, you also need to divide your enthalpy also by the same number. So that would be 206.5. Right? So yeah, so the closest one is 206.1. Yeah, so that is the answer. That's how you would manipulate the equations to get the target reaction. Sometimes you need to reverse it, so the sign need to be reversed, enthalpy value. And also if you multiply or divide, you also have to multiply and divide your enthalpy values as well. Okay, all right then, that's all the questions. I'll talk to you again soon.